Welcome to the MetaConnex for New Zealand workflow in detail within 12D model. I'm Charlie Latchford. I work for 12D New Zealand, based down in Otago in the South Island. So this follows on from our talk that we did for the overview within the main room. So now with inside 12D, we're looking at version 15. We've got the new survey themes that Darlene's going to be talking about, but as part of that we've actually got this new ribbon toolbars that we've actually got within 12D. So on the screen we've got the code of practice, XSD, and the XSD is the business rules that define the asset classes. So if I just open this up and make this a bit bigger on the screen, we've got this. In this case, this is a pipe. The code of practice has 6 different classifications of an asset. So a pipe covers all the different features. So if I come down here on the left-hand side, we have got all the attributes that have been named and required for the code of practice. You can see some down the bottom here are grayed out. They are you can turn them on or non-requirable. But everything else is pretty much you have to have on within the code of practice. Under the network type, you can see that we have a option here that we have a blue downward facing arrow that does your different assets types, so in potable water, stormwater or wastewater. The beauty of the XSD is we've got these drop downs, so there's no spelling mistakes, there's no uppercase or lowercase errors within it. If we go down a bit further down within 12D, we can actually calculate based on your survey information, the from invert level. 12D will calculate the Z, or use the Z value, I should say, for that you've observed out in the field, and then do some other calculations, the 2 depth, and you will use the tin depth from there to calculate from one height to another and input the values. So we'll cover this in detail, and also Paul Hardwick is going to go into specific detail of the macros that he's created for the MetaConnex. So that's the values that we need to require for this pipe. We've also got some logic in there. So in this case, we've got a pipe shape and it's circular. We have to apply the internal, nominal, and external value of a circular pipe. But if I would say that, hey, this is actually a rectangular pipe, I've got to apply the pipe width and the pipe height. So we've got some logic choices in there. The same for materials. If I delete the material, we can go down there and we've got all these different choices we can have in the assets. We can also, everything is fully 3D. So every single vertex of a pipe, probably a water pipe, will actually be captured and transferred to the council. We're fully 3D. If we now look at the XSD for the other assets, this is something that you probably won't see once you start working in the process. You just got to understand that the XSD defines the business rules in the back end of the code of practice, but generally the surveyors will never see it again. They'll just understand it. It's there. So I've got some raw survey data here. There's not much detail. These are either points and lines, which is down the bottom here with some manholes, or I can actually have attribute data in there. So if I go and pick this segment here and look under the string, you've actually got attributes. So if your controller has the ability to enter attributes into the machine when you're recording observations, you can put attributes, and that drives the whole process and saves a lot of manual entry and work. So what I've tried to do is remove the need to change your field processes, but we have been working with Leica, Trimble and Magnet to produce a field file based on the code of practice that has the ability to put attributes into the controller and using our names. But if you don't want to do that, we have the ability to use a map file, and the map file will based on the string names out in the field, map things to the code of practice naming convention. So in this case, I can actually go and have that that has been mapped to WWPM. And if I were to look at the attributes of the project, if I was to look at the attributes of this string, a pick, you can see now that it's actually added in the internal and the external values based on the map file. I've got the names, A bar 4 in this case, of that chamber, and that's where we can calculate the upstream and downstream node numbers and put that on the pipe. So that's probably the only part of the manual entry that I've done in this process of adding these pit names. If you have the design strings or the design stuff from the drainage network, then you can use those attributes if you needed to. Within this process, we've actually got the ability to enter information as a global attribute, and this drives the macros in the background. So if I were to come up here and edit my global project attributes and open this panel defines a lot of the rules within the project, and it's actually used within my plan generation and passing the information back to the council as a project attribute. So in this case, it's got the coordinate system, Mount Nicholas 2000, that we use to convert within FME from Mount Nicholas to Transverse Mercator. I've got my origin points, I've got my levels, and my vertical datum and everything. My permit number, this is the ability, I have the ability to put this in once and it will propagate to all of my projects for assets. I have my construction date and everything else in there for the code of practice. The next tab is our user non-definable things. So in this case, if I was to zoom in here and I would turn on my Z values, we know for the part of the calculations of the maths, we know what the model is for the manhole chamber. So if we go the chamber model, that's the chamber model. We know the pipe model here. We can do 12D can work out the depth. So we know the lid level, and 12D will search within a certain radius, which is user definable, for all the pipes that come into this chamber. Do a search in what in this case 1.5 meters, and goes and finds the lowest pipe out of these four, which will be this one. Define that is the outlet of that pipe. Then it can do the maths between the lid level and the outlet and work out the depth of the chamber. We also can do that for our stormwater, our portable water. We can have your average depth below a tin. So we define a tin in there. We can actually have our laterals. If I zoom out, we can have our laterals going into our property. So if we know that that lateral crosses the property boundary, we can have an attribute of the lot number, and it will display in the system that that is the lateral for the code for that lot. We can even check against design strings as well, and we'll look at that a bit later in the process. So if I go process, it's set all my global attributes, and if I were now to go to projects, management, oh, I have to cut that out. If we were to come across here to management, utilities, attributes, and you can see under here the COP, you can see that the attributes now are in the global attributes, and we can start using those model names for the calculations. So I finish that tab, and I can finish that tab. If I turn off my Z values, and I'll turn off my node chamber numbers, I don't need that anymore. So I'm going to start applying this. So what we're going to look at is the code library. Paul Hardwick's going to go into detail with this with his MetaConnex review. But if I just go back into this pipe, which is our WWPM pipe, and scroll down here and look, it's going to get the string attributes, internal int underscore diameter, and times that value to by 1,000. That's what we need it as a whole value within the code of practice. So it's pricking those attributes from the field, and same for the nominal and the external. If you didn't have that, you have the ability to go and actually put in specific information. In this case, I've got a code called WWPM150. And if I go under the material type, and I can go in there, and I've actually entered a value of 150 for the nominal, internal, nominal, and external value. Anything else in this, you would actually go through. So anything with the same code of WW150 will be, the values will be actually be entered from this thing. So like the owner, I've got the project attributes, COP generic owner. So I've entered that information once. That will propagate into this asset. So really, what does that mean? I'm going to go and apply these strings to these models. So everything in that view will be applied with the map file. I have the ability to replace existing attributes. If I've got some existing assets that I'm just adding information to, I can overwrite everything if I needed to, or I can keep the existing information. So I'm just going to replace the existing attributes because I'm just going to rerun this. I'm going to go process. It's got a highlighted that this code here is not in my map file. So I've got two ways of doing things now. I can either go back into my map file and add that code in there, but I know for a fact that this code that I've done is incorrect. So I'm just going to come up here to the global change. I'm going to go, I want to change the same as that one. Pick that pipe and replace existing. So now if I go process, I've got no mismatch, but I need to now validate that this information is correct. So if I go to the next icon along the validate attributes, I'm going to validate everything in this view against my map file, and I'm going to go process. And I'll come back to the missing mandatory in a second, but I've got the ability I've got no mismatch codes. I've got some invalid data. So if I go invalid under the laterals, I know that I have got a value outside a maximum minimum. So if I put a maximum value for, in this case, cover, well, I've got to make sure that I have I've put in between 0 and 300 is the maximum, well, the minimum cover that I need. So I break that. So I'm giving my validation rules, and I've got the other way as well. If it's more than 1.2 meters deep, I actually get an error in there because the contractor's installed that too deep. So there's some logic checks in there. Missing optional. Unfortunately, the code of practice does have some information that we don't need to provide to the council. So like the rehabilitation method, the serial number, and those kind of things that they would use within their asset management system. So we've put those and coded those as optional. So you can go back into the map file. I bring that back across, and you can see down here we have a tick box in there. So we can select it as being optional or not optional. And under here, the missing mandatory. So we've got a few errors. So this isn't a valid file. And if I zoom in there, you can actually see it tells me exactly what attribute is missing, and it says it's not actually appeared. So it takes me directly to that model. So I know that these are all exactly the same. These are node to node length, where the GIS people want to have the true virtual pipe, but join this point to the center of the chamber. It's not correct. It's not the true length or grade of the pipe as the surveyors and the engineers wants, but that's the way the GIS wants it. So I've got another little tool in here, which is called node to node distance. Effectively, that joins a pipe, creates an extra node from that point that we surveyed the center of the where it meets the chamber into the center of the chamber. So extends it by half the chamber width, and it calculates the length from there. So I've just got a little chain that runs in the background. This gets a bit flashy. So that's done its calculation, or it's just working on it. And if I go down here, I've got to process that data again. The process, if I've got that tick box on, it just recalculates all the attributes. So you can do as many times as you want. It's not creating the extra attributes. It's calculating them every time. So if I come back into here, and now I know that I've missed all those node to node lengths have been calculated, I can actually go back in and look at the attributes. If I go under the data tab and pipes, you can see all these attributes that have been calculated on the system by the macro. We've actually got some 12D calculations. We've actually got things over and above the XSD that we calculate predominantly on these laterals. If I go onto this lateral, we can see here we've got the nearest and the others. They're the lateral offsets that we're going to annotate on the plans a bit later in the process. We've also got the ability that strings property attributes is quite a cumbersome thing to look at, but we're within 12D, we've actually got our inquire option. So if we are under here under project and settings, we can turn on our super inquire, and if I change my default to MetaConnex and go set, and now do the same F2, the MetaConnex come up, picks, you can see that I have now got all the attributes have been displayed on an F2 inquire. It saves a lot of time. Okay, so that's the sewer, and generally the way I work is I work at one asset at a time. So that's the sewer. I'm happy with that information. I'll then go on to my stormwater and then my potable water. So if I were to remove all my sewer assets, and then I'll go into my stormwater. Again, you can see that I've got the asset numbers for all of these. Well, I don't really actually need to know. I've got a bit more information in here. I've got my laterals. I've got my catch pits. I've got my catch pits laterals going to my center of my to my manholes, and these red lines are subsoil drains. So I'm going to do the same process. I'm going to apply the attributes to here to see if everything's correct. So I've got no missing codes, but that doesn't mean that the information that I am giving and calculated is correct. So I've come back with this validation tool. I've got no missing mandatory in here. I've got a few more optional attributes that are required. It's like the warranty and the serial number. I've never seen a serial number on a pipe or a chamber, but that's what's required within the code of practice. I may have some more values attributes. I've got here that this lateral down the bottom is over the 1.3 meter, though actually the contractor has laid that too deep. So if I clear that, that removes the signal from there. So I'm kind of happy that the stormwater is okay. I would then go on to the potable water next. Within the code of practice for the potable water, there's quite a few things that need to be required. The code of practice requires that an asset has a pipe asset, I should say, should have a start point and an end point. In this case, it would be a water tapping band, and the end point will be a water toby or water meter. Down here in Otago, we actually have one box that has both assets in there, so two different types of assets. And we need to have unique identifiers on each of our hydrants and our valves, and a unique identifier on our pipes. So I've got a chain that actually creates the node to node, not node to node, the unique identifier for the water assets. If I apply that chain, it will go through and do a filter selection. And the filter selection will find every single one of the valves, the fire hydrants, and put a unique number starting at 1 and then progressing through, and the same for the pipes. So if I just run that now, you can see that 12D has gone and put a unique identifier on the point ID. So if I actually down here, the point ID has been given the name. Now it's been calculated the point ID. That is a part of the vertex. We can actually do the calculations and take that information there. And the same for the pipe. We've now given a name on the pipe, so we can do that. So if I just turn off my point IDs, I process my information. I've got valid data, but now if I were then to go and process this, I've got a missing mandatory thing here. One of those would say, I haven't actually got a serial number for my water meters. There's an easy way to manually enter this information into 12D. Could be quite a slow, laborious process, but we have the ability to output these attributes to a CSV file, and then use the power of Excel to update attributes. But also, if you're the surveyor and you don't know information, you could pass attributes or the data as a CSV file to, say, the project manager or the engineer. They can enter the values, and once they've entered the values, you can then put that back into 12D. So under the utilities, attributes, CSV file, we can actually write attributes. So in this case, I'm going to select a single model, and that single model will be my water meters. I'm going to output this as a comma delimited file. Meters.csv. And if I go down here and select an ANSI format and run that file, I can open it. I have the ability there, the attributes that go out, as long as you can change anything in there, a bit like the drainage network editor when you export that out, as long as you don't change the element IDs and the model IDs, you will be okay. So if I go all the way out to the end, and I go insert, I'll make that just a bit, I'll just hide some of these because it's just a bit of a pain. I've created this extra blank area. So there's nothing in here, but I can get another value that I've for those codes. I can actually bring that in. I know it's a text type. And I can go, I'll give it a meter number of 210813, serial number 001. And I can use the power of Excel to put those in. So that's a value. If I just save that file, I can close that file, come back into 12D and go utilities, attributes, CSV, and we can read the file this time. I'm going to go into that one. So if I read that file in, I've got the element 16 has been successful. And if I were to go in and do an F2 inquire, and my meter, you can see it's actually got the meter number in here. It's not displayed, but it's actually put the value. So if I go and validate it, I have now have to re-edit that to draw in those points back to there. So if I were to go under utilities, attributes, CSV, and read attribute files, I'm going to select that file that I had a minute ago, make sure it's a comma delimited, and go run. So I've got successfully read in 16 elements. I've got to reapply the attributes because that has come through. So if I go process and then recheck those valid attributes, I have to re-edit quite a few things there back to where I'm re-entering these attributes. So if we go back inside of 12D, if I read these attributes now, so that file, and make sure it's a comma delimited, I'm going to read it. Well, 16 elements that's been successful. I've now then got to apply the attributes. So I've brought that back into 12D. After I bring that back across and I go process, I've now not got any missing mandatory data. So in effect, that portable water now is a valid file. So if I just finish these panels, I should say, and I'm just going to go to a view favorite and bring all my services together. So I've got my property boundaries, I've got my portable water, I've got my stormwater and my sewer. So basically my 3 waters assets. And I'm going to run now the next part of the process. This is going to apply everything together. It's the same as the apply attributes, but it's going to do a few other things in the background. So the chain will go away and run. It's got a sleep of about 10 seconds in there. It's calculating about 800 to 900 attributes, so it does take a couple of seconds. It just gives me some updates there for some rendering, and you can now see that I've got my data in fully 3D based off of all the information, the diameters of the chambers. So now we've got it in 3D. We can actually inquire around and look at it. I know that I've got a few little batches in there. One of those would be the fact that if we look at this chamber here, the pipes don't meet in the middle. That's based off the code of practice defines the center of the chamber as being the center of the steel lid, not the physical chamber. I know that these manholes, these pipes actually met the side of the chamber as it met the manhole, but it's defined on the chamber. And the other thing in here, we've got some clashes detections. You could go around and visually have a look at this, but we have inability in 12D to do some clash detection. So if I go under utilities, A to G, and we can go check clash, I can run some rules against this. And when I go the rules, I want to check against, in this case, the MetaConnex, which is always down the bottom here, my stormwater versus my water. So I've got a left and a right tolerance for any pipes, and it will actually propose me, if there's any crosses within there, it will give me some tri-meshes. So if I just turn on my clash files, you can see that 12D has highlighted that sewer line runs through that stormwater pipe. So hopefully you wouldn't be having that, but I know a few projects where they're putting asset by asset, so they're doing the stormwater first or the sewer first, and they're designing the other assets based on what they pick up through the installation. So you can do the attribute as-built information, you can pass that to the designer so they make sure that there's no future clashes. So now we've kind of got that process, and you go around and your QA, we've got the information. The other part is that 12D comes in and creates consistent symbology and line work. If I actually go into here and switch on my faces, you can see my edges are actually drawn for my property boundary. I've got consistently looking plans that will go for the council. These are fully attributed up, but now I need to create all my labels for my plan generation. We've done the same thing. We've created a little chain down here that goes off and creates all my labeling. So I'll let that start. So if I were to go into my stormwater, in this case, it's got the name of my assets and it's got the upstream and the downstream values. I've just gone in and changed the order, so the display order, and now you can see that that text is actually on the front, so it displays better. We have the ability to show the attributes on the plan either as text, but if it goes, if it's too small and too close, we can actually change that straight as a leader if we were needed to. You can see in here, if I change the view scale down to say 1 to 250, you can see that we have got the offsets from the lateral end to the nearest point and the other. We've got the surface level and we've got the annotation of the depth of the value. So if I were actually to go into the string and have a look of this pipe under the code of practice, we have got some 12D calculations and we can do our lot number. So I know this is lot number 7. I've got my nearest offsets and I've got my other offsets, and they're the values that show up on the plan, and they're built above the XSD. So finally, we want to actually do some plan generation. Within 12D, we've actually got our multi-sheets. Dylan and others are going to actually cover this in a lot more detail, but if I come in here and go under my multi-page plots, I've already got a plan set up. Unfortunately, this is a bit hard to show and demonstrate on a single monitor. Normally, I'd have these two panels on another monitor. So if I'm reading that through from our customer library, I've got a code of practice file. I go read. We have the concept in multi-sheet plots of a book, a chapter, and a page. So if I open up under my Stormwater, I can see I've got a Stormwater chapter and I've got a page of 400. So if I click on the 400, it gives me a preview of how the plot would actually look. If I move this to the side, you can see I've got that red box, so my preview window. So if I want to create a next page, which I need to because it doesn't cover all these files down here, I'm going to come in here and go, okay, I want to copy page number 400, and then I want to paste it. So then pasting all the information, I have to give it a unique page number. In this case, I'm going to call it 401. And I'm going to go under the frame and I'm going to go translate. I'm going to translate it across there if I needed to. So that picks up in my location of my covers all my assets. I can rotate it if I wanted to. Not that I want to, but I can do in this case. I can rotate that, and you can see if I move that back, I've got a preview of the data and my north point automatically rotates. But if I just put that back to 0, I can then plot this information out. So I've got a chapter for a sewer, potable water, and my roading. My roading doesn't cover within the code of practice. That probably will be the AMDS with the Wakatakahi standard, but we're just showing it for context here. I have the ability to plot this out as a single book, a chapter, or a page if we needed to, but in this case, I'm just going to plot the book. 12D will go off and plot those 8 or 9 pages as a single PDF. You can actually have single pages if you needed to. So there's no need to export this file for plotting out to something like CAD. If you do, you would lose that association with those clever smart text displays and you're moving. So it will probably take you, if you're having rework or doing any changes, it will actually cost you more in time. And it's come up on my other screen, of course. There's my PDF. You will have to do some sort of plan moving text around, but it's got 80% to 90% of the attributes there, well, not attributes, the labels in the correct location, you probably will just need to move and tidy it up process. But if I look down here, this is a standard 12D title block file that we supply. It picks up the plot frame, picks up the attributes that we entered in the global attributes and propagates it into your system. And you can see if I move across, again, it's the examples, and it has the page numbers, and it has the discipline. In this case, it would be my stormwater. So if I would go through and look at my sewer, it picks up my sewer information. So once I've got my plans and I'm happy with everything like that, I'm just going to write this into my working folder. So it's just working my right working folder. So if I come in here again, I can just open that up and off I go. So I can finish that file. Now I've got valid information. I don't need to convert that to transfers from Mercator. I just need to put all those assets into a view, and I'm just going to create a view. So view, create a view, yep, plan view. And I'm just going to all do my complete data. I don't actually have to do the labels. So I'm just going to remove all my labels. That's information will go to the council. I can then output a 12D XML file. So file, output, 12D XML data. So everything in this view, it has to be a normal 12D XML file. It can't be zipped. And you do need to make sure that you output the project attributes. The project attributes will have things like the coordinate system, the RM number that the FME models will actually consume. So if I write that out, that information, that file can then be sent to the council. If I just quickly jump back into PowerPoint. So this is a real world example of a subdivision that has gone through the 12D process. That's the information in 12D before it was exported. This is the FME workbench model that surveys won't see. That will be down to the council for them to do the processing, but that is the same information inside the council's GIS system. Well, thank you very much for coming and have a look. But if you have any questions, please let me know. Thank you.